Hello everyone. I am sure that you know about this thing. What is the value of 1 plus 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube plus 1 upon 2 raised to 4 and it goes to infinity. During your school level, you already learned that this is nothing but 1 upon 1 minus 1 upon 2, which turns into 1 upon 1 minus 1 upon 2, which is equal to 1 upon 2, and so therefore this is equal to 2. Right. Now let me rewrite the left hand side again. So this is 1 plus 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube plus 1 upon 2 raised to 4 and so on. Now if you concentrate on left hand side, then what is the left hand side? The left hand side contains the sum of infinitely many numbers. So do you believe that the sum of infinitely many numbers is just one particular number? So here the sum of these infinitely many numbers is called series. So in general, the notation for the series is summation an, where n is running from, you can start from 0 to infinity. In place of 0, you can start from 1 to infinity. In place of 1, you can start from 2 to infinity, or you can start from any finite place. So in general, you can write the symbol of series as this: summation an from the lower bound capital N and the upper bound is infinity. Now we have two situations here. This is the sum of infinitely many numbers. So this sum is either a number. So suppose this is equal to L, or this is infinity. Suppose it is not a number. For example, if you are writing 1 plus 1 plus 1 plus 1 plus 1 up to infinity. So obviously this is equal to infinity. So what is happening here? The sum of infinitely many numbers is infinity. Whether here the sum of infinitely many numbers is a particular number. So both the cases, this is the case for infinity and this is the case for L. So in any series, if the sum of infinitely many numbers is L, it is called convergent series. Convergent series. And suppose the sum is not a particular number, then it is always infinity and the series is called divergent series. And this is always the question for the mathematician, that for any series, whether it is convergent or the series is divergent. So here I have mentioned some particular test which gives me the guarantee about whether the series is convergent or the series is divergent. Now you know what do we mean by the convergent series? The sum is a number. And what do we mean by the divergent series? The sum is infinity. One important series you already learnt during your school level is known as geometric series. So let me explain you first what is happening with geometric series. So suppose you are on the particular field. This is the playground and a student is playing a cricket. Right. The batsman hit the ball and this is the motion of the ball. And the ball is going towards the boundary in this way. And this is nothing but the physical example of the geometric series A plus AR plus AR square plus AR cube up to infinity. and this is nothing but a upon 1 minus r only if the absolute value of r is less than 1, and this is equal to infinity if absolute value of r is greater than or equal to 1. So for example, if I would ask the question, what is the summation 2 raised to n upon 3 raised to n when n is running from n is equal to 1 to infinity? Then if you observe this, then when n is equal to 1, this is 2 upon 3. When n is equal to 2, this is 2 square upon 3 square. When n is equal to 3, then this is 2 cube divided by 3 cube and so on. This can be represented by 2 upon 3 plus 2 upon 3 whole square plus 2 upon 3 whole cube plus 2 upon 3 whole raised to 4 and so on. Now if you compare this series with this one, then the first term is a, which is 2 upon 3 plus 2 upon 3 into 2 upon 3 because we need a into r, right? So in general, if you observe this, then this is nothing but a into 1 plus r square plus r cube and so on. So to get this relation, I take 2 upon 3 common here. So I have 1 plus 2 upon 3 plus 2 upon 3 square plus 2 upon 3 cube and so on. Now if we compare this, then a is equal to 2 upon 3 into 1 upon 1 minus 2 upon 3, because this is our a and this is our r. So a into 1 upon 1 minus r, and which has simplification. This is nothing but 2 upon 3 into 1 upon 1 minus 2 upon 3 is 3 minus 2, which is 1 upon 3, and therefore this is equal to 2. What does it mean? The value of the sum of infinitely many numbers 2 raised to n upon 3 raised to n is equal to 2, and therefore at last I would like to say that this series summation n equal to 1 to infinity 2 raised to n upon 3 raised to n is convergent, because the total sum is a particular number which is finite number. But sometimes it is difficult to say what is the sum. For example, I have given this series 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5 and so on. This looks very easy series, summation 1 upon n from n is equal to 1 to infinity. But if we look this series mathematically, then this series is divergent. What do you mean by the divergent series? Summation 1 upon n from n is equal to 1 to infinity, which is infinity. And this is unbelievable because we have given 1, we are adding half, again we are adding 1/3, we are adding 1/4, 1/5, 1/6, and infinitely many times we are adding very much small quantity, again small quantity, but the final sum goes to infinity. And so Whenever I have given any random series summation an from n is equal to capital N to infinity, it is always difficult to say whether it is convergent or divergent. So here I have mentioned some important tests. The first test is the zero test, the second is geometric series, then integral test, p series test, limit comparison test, ratio test and root test, and alternating series test. These are few some important tests to check whether series is convergent or the series is divergent. So let us start with to discuss the examples of all these particular tests, and then later on we shall discuss that if we have given any random series, then which test will be helpful. Summation n equal to 1 to infinity 2n upon 3n minus 1. If you observed the examples of series, then definitely you can say this thing 1 plus 1 plus 1 plus 1 is equal to infinity. Okay, so here question arise, how do we solve this example? So let us start with summation an, where n is equal to 1 to infinity. This is equal to what we have given. Summation n is 1 to infinity twice n upon 3n minus 1. By the simple comparison, we have an is equal to 2n upon 3n minus 1. Now for this particular example, we apply zero test. So what is the zero test? The zero test is this. If I have given any series a1 plus a2 plus a3 plus an and up to infinity, then I look at the nth term. So here my nth term is an. I take limit over infinity. That means actually I am looking to the infiniteth term. If the infiniteth term is not equal to 0, then definitely the series is divergent. But the question is, suppose this term is equal to 0, then what? Then we cannot say anything. So the zero test is the necessary condition for the convergent of the series. It is not sufficient condition. So if you could prove that limit n tends to infinity an is not equal to 0, then with guarantee you can say that it is divergent. But suppose this limit is equal to 0, then we are not sure about its convergent or divergent criteria, and in that case we need the other tests to check. So let us see what is happening here. When I apply limit, so limit n tends to infinity an is equal to limit n tends to infinity 2n upon 3n minus 1. This is equal to limit n tends to infinity 2n divided by, if I take n common, then in the bracket I have 3 minus 1 upon n. You can cancel out this n and this n. And you also know that when n tends to infinity, 1 upon n tends to 0. And therefore, this will become 2 divided by 3. And you know 2 divided by 3 is not equal to 0. In the left hand side, what we have? Limit n tends to infinity an. So, by this limit n tends to infinity, an is not equal to 0 and therefore the series is divergent. And so the series summation an, which is equal to this summation 2n upon 3n minus 1 from n equal to 1 to infinity is divergent. So here the exercise is summation n equal to 1 to infinity n into e raised to minus n square. So let us start with summation an. This is equal to summation n into e raised to minus n square when n is starting from 1. This is equal to summation n is 1 to infinity n over e raised to n square. And so what is our an? An is equal to n upon e raised to n square. Now at this stage we have seen only two tests. One is zero test, another one is geometric series. And you are damn sure that this series summation n into e raised to minus n square is not geometric series. That means geometric series test will not help us. Now only this case remain whether zero test will help us or not. So for the zero test, what we are doing, we just observe limit n tends to infinity n upon e raised to n square. And as you know that exponential function is highly increasing function than n and therefore the limit is 0. Right. So by the zero test, what we can say, what is the zero test? If limit is non-zero, what we can say by zero test? If limit is non-zero, then we can say that series is divergent. But suppose limit is equal to 0, then what? Can we say it is convergent? We cannot say it is convergent. Here the limit is 0. But by zero test, we cannot say that it is convergent. That means we are in that situation where geometric test is not helping as well as zero test also not helping. Right. So let us define one more test here, which is called integral test. So let me explain what is integral test. The integral test is where we assign the continuous function. How do we assign the continuous function? That is important here. So the test says I have given the series, the corresponding I have the integration of f of x, the lower limit is the lower limit of the summation, upper limit is the upper limit of the summation. I integrate this quantity. I don't know whether this is convergent or divergent, but if I can integrate this thing, I definitely can say whether the integration is finite or the integration is infinite. So suppose the integration is finite, I can say that the series is finite. If integration is infinite, the series is infinite. Series is infinite means what? It is divergent. Series is finite means what? It is convergent. So if this is convergent, the series is convergent. If this is divergent, the series is divergent. So in this case, what we required, the important thing is how do we find the function f of x? And there is a trick to find f of x, and the trick is what you have to do. The corresponding f of x, you just replace n by x. So this is x upon e raised to x square. Here I have n, I replaced by x. Here I have n, I have replaced by x. and which gives me the function of x. Now what I do? I integrate this f of x. What about the limit of the integrals? My lower limit becomes the lower limit of the integrals. My upper limit becomes the upper limit of the integral, and therefore here the limit is x is equal to 1 to infinity. What is my function? X upon e raised to x square dx. So let us see what is happening here. If I assume x square is equal to t, therefore 2x dx is equal to derivative of t, and therefore x dx is equal to 1 upon 2 dt. So this integration is equal to x dx is 1 upon 2 dt, and e raised to x square becomes e raised to t. I have to write the limits in terms of t. So when x is equal to 1, what is my t? When x is equal to infinity, what is my t? So when x is equal to 1, therefore x square equal to 1. When x is equal to infinity, x square is equal to infinity. And what is my x square? X square is t. So t is 1 and t is infinity. That I substitute here. So t is equal to 1 to t is equal to infinity. And therefore this integration is equal to 1 upon 2 integration e raised to minus t dt equal to 1 upon 2 integration of e raised to minus t is e raised to minus t upon minus 1 from t is equal to 1 to t is equal to infinity. Now when you substitute t equal to infinity here, it is e raised to minus infinity, which is nothing but 1 upon e raised to infinity, which is 1 upon infinity, and 1 upon infinity is 0. And so this becomes 1 upon 2, upper limit has value 0, minus sign for lower limit. When t equal to 1, this is e raised to minus 1 upon minus 1. And so the final answer is integration f of x dx from 1 to infinity is equal to 1 upon 2. So here this integration is a particular number which is finite. That simply means that what is the meaning of the integration value is 1 upon 2, that this series summation an, that means this series will not have value more than 1 upon 2. Not more than 1 upon 2 means what? It is a particular number but which is not larger than 1 upon 2. So definitely it is not infinity, right? So how do you end this exercise? Therefore, by the integral test, this is finite. So summation n is equal to 1 to infinity is also finite. That simply means summation n is equal to 1 to infinity is convergent. Here in this example, we have given the series summation n equal to 3 to infinity n minus 2 upon n cube minus n square plus 3. So if we compare the series with summation n equal to 3 to infinity an, therefore the term an is equal to n minus 2 upon n cube minus n square plus 3. Now to check whether the series is convergent or divergent, how many tests we have? We have already seen zero test, geometric test, and integral test. So let us see that out of these three is any test. Out of these three tests, does any test help us or not? So the first is zero test. In the zero test, if the limit an over n tends to infinity is not equal to 0, then only it will be helpful. But if you observed here, then this term tends to 0 as n tends to infinity, and therefore this test will not help us. Now we have geometric series test. If you observe that the ans are not in geometric progression, and therefore geometric series test will also not help us. Now in integral test, what we do, we find the corresponding function f of x. How do we find f of x? We replace n by x. So if I replace n by x, then I would have f of x is equal to x minus 2 upon x cube minus x square plus 3. And due to integral test, I need to integrate this f of x. So I need to integrate this quantity with respect to x from 3 to infinity, 3 to infinity. And as you have observed that integration of x minus 2 upon x cube minus x square plus 3 is quite difficult. That means I'm looking for any other tests which gives me the analysis of the convergent or divergent in very simple mathematical analysis. If you read the statement of limit comparison test, then it has two quantities. One is the series which we have given and another series which we choose. Right. Then just like integral test, both the quantities either are convergent or the divergent at the same time. So here both the series are either convergent or divergent. Now the given series, we don't know what is the nature of the given series. Right. So I have to assume the series in such a way that the nature of this series is known. Right. So whenever I choose any series, I must be sure that my choice gives me either my choice is the convergent series choice or divergent series choice. Right. So that choice is very much important. How do we choose that series? Let us discuss here. So for this particular exercise, choose summation bn n is equal to 3 to infinity such that, now see how I am choosing the new series. Observe summation an. Summation n contains two things. It has numerator as well as denominator. What is the numerator? Numerator is n minus 2. What is the denominator? N cube minus n square plus 3. Now observe the numerator. In the numerator, we have two terms. One is n, another one is 2. So the maximum degree term is this n. So let us choose n first. So from the numerator, I am choosing n. And in the denominator, n cube minus n square plus 3, the highest degree term is n cube. So let us choose n cube. And so what is the quantity? N divided by n cube is 1 upon n square. And that is my choice. Summation n is equal to 3 to infinity 1 over n square. This is the best way. How do we choose summation bn? Just after few minutes I shall explain what is the importance of this choice, and why I have to choose only this bn. Now, what is the limit comparison test? I have to take ratio of an and bn and take its limit over infinity, right? So what is bn here? Therefore bn is equal to 1 upon n square, and therefore limit n tends to infinity, a n upon bn is equal to what? Limit n tends to infinity, a n is this n minus 2 upon n cube minus n square plus 3 divided by bn 1 upon n square. This is equal to limit n tends to infinity, n minus 2 upon n cube minus n square plus 3 multiply by n square upon 1, and hence this is limit n tends to infinity, n minus 2 into n square is n cube minus 2n square divided by n cube minus n square plus 3. So if you take n cube common from the numerator and denominator, then what is this? N cube into 1 minus 2 over n divided by n cube into 1 minus n square upon n cube is 1 upon n plus 3 over n cube. And you know that if n tends to infinity, 1 upon n tends to 0, and therefore this is equal to this n cube cancel out, this is 0, this is 0, this is 0, right? And so the final answer is 1 upon 1, which is 1. Therefore limit n tends to infinity, a n upon bn is equal to 1. So if you observe here, limit n tends to infinity, a n upon bn is equal to c, and c must be non-zero. So this is 1 which is not equal to 0, and therefore by the analysis both the series are either convergent or divergent. That means given series summation an and summation bn both are either convergent or divergent. What does it mean? If summation bn is convergent, summation an is convergent. If bn is divergent, then summation an is also divergent. Now the question is, we don't know summation an whether it is convergent or divergent. But do we know what is summation bn, whether it is convergent or divergent? Yes, we know. How? Using p series test. See, what is p series test? Summation 1 upon n raised to p. And this is the stage where we are using p series test. Is convergent when p greater than 1. What does it mean? P greater than 1 means summation 1 upon n square, summation 1 upon n cube, summation 1 upon n raised to 3.5, summation 1 upon n raised to say 2.1, summation 1 upon n raised to 1.23. All these series are convergent because of p series test. 0 less than or equal to p less than or equal to 1, that means summation 1 upon n raised to 1, that is summation 1 upon n. which is divergent. Summation 1 upon n raised to 0.99 is also divergent series. Here given series is summation 1 upon n square. So p is equal to 2, which is greater than 1. So by p series test, this is convergent and therefore this is convergent. So how do we mention in exercise? Both are convergent as summation bn is equal to summation 1 upon n square is convergent. I'm writing CGT because of P series test. And this is the end of exercise. So here exercise number 4, summation n equal to 1 to infinity under root n plus 4 divide by under root n raised to 4 plus 4. So let us work with summation an is equal to this, and therefore an is equal to under root of n plus 4 divided by n raised to 4 plus 4. This is given. I have to choose my summation bn, and this choice must be appropriate. How do I choose the appropriate choice? From the numerator, I look at this numerator n plus 4. So from the numerator, I choose n. This is the denominator. From the denominator, I choose n raised to 4. Right. And this square root symbol is the additional quantity. So I write that square root symbol. And so this quantity is nothing but under root of 1 upon n cube. This is nothing but 1 upon n raised to 3 divided by 2. So my choice of bn is 1 upon n raised to 3 upon 2. And you know what is 3 upon 2? 3 upon 2 is 1.5. And now limit n tends to infinity, an upon bn is equal to limit n tends to infinity. What is an? Under root n plus 4 divided by under root n raised to 4 plus 4 all divided by bn. And what is bn? 1 upon n raised to 3 upon 2. And so this is equal to limit n tends to infinity, n plus 4 raised to 1 upon 2 divided by n raised to 4 plus 4 raised to 1 upon 2 multiply by n raised to 3 upon 2 divided by 1. Now I left this on you, and you have to prove that this limit is equal to 1, which is not equal to 0. This is important. You must mention that this limit is non-zero. This non-zero limit mentions that this summation an and this summation bn are having the same nature. And what is the nature? Both are either convergent or both are either divergent. Clear? And so here summation an and summation bn both are either convergent or divergent. Now you have to apply p series test on summation bn. What is p series test? When p is greater than 1, the series is convergent. What is p? is equal to 1.5, which is greater than 1. Therefore, this series is convergent, and so summation an is convergent. Right. So let us mention here. Therefore, summation an and summation bn both are convergent, as summation bn is convergent because p series test, and this is the end of exercise. Now for this example, summation n equal to 1 to infinity 2n factorial upon n factorial into n factorial. What is my an? Here our an is equal to this 2n factorial upon n factorial into n factorial. Now I am not going to discuss that if you apply zero test, then zero test will not help us. This is not geometric series. Integral test cannot be applied here because suppose if you are thinking to convert this into x, then do you know what do you mean by 2x factorial upon x factorial into x factorial? Actually, this is not defined. Factorial is defined only for integer numbers. If x is any real number, then 2x factorial has no meaning. So the integral test also will not help us. Limit comparison test, p series test, how do we compare this with any kind of polynomial terms? That means whatever the tests we have so far, they are not going to help us. But we have two more tests, that is ratio test and root tests. Both the tests are having same analysis. If the ratio at infinity is L or the nth root at infinity is L and the value of L is less than 1, then it is convergent. Greater than 1, it is divergent, and equal to 1, then the test is inconclusive, means this test will not help us and we need the further mathematical analysis. So let us apply here ratio test. So in ratio test we need nth term as well as n plus 1th term. What we have? An is equal to 2n factorial upon n factorial into n factorial, and so an plus 1 is equal to 2 times n plus 1 factorial divided by n plus 1 factorial into n plus 1 factorial. So this is nothing but 2n plus 2 factorial divided by n plus 1 factorial, n plus 1 factorial. What we have to evaluate? Limit n tends to infinity an plus 1 upon an. So what is this? Limit n tends to infinity an plus 1 is this 2n plus 2 factorial divided by n plus 1 factorial into n plus 1 factorial. Divide by an is this multiply by n factorial into n factorial divided by twice n factorial. So let us see what is this quantity. This is equal to limit n tends to infinity. Now see, this n factorial and n factorial remain as it is, n factorial into n factorial. Now this n plus 1 factorial is what? You know that it is nothing but n plus 1 into n factorial, right? So this is n plus 1 into n factorial. Again n plus 1 factorial is this n plus 1 into n factorial. 2n factorial as it is. 2n plus 2 factorial is what? 2n plus 2, 2n plus 1 into 2n factorial. Now, how many terms we can cancel out? N factorial, this n factorial, then 2n factorial. And so the remaining quantity is limit n tends to infinity 2n plus 2 into 2n plus 1 divided by n plus 1 into n plus 1. Now if you take n common from both the terms, take n common here, take n common here, right? So we are taking n square common, likewise we are taking n square common. If you have any other logic, then you are free to apply. And this is 2 plus 1 upon n, this is 1 plus 1 upon n, 1 plus 1 upon n, and so this is equal to, I can cancel out n square, when n tends to infinity 1 upon n tends to 0, so this is 0, this is 0, this is 0, this is 0, and so what I have, 2 into 2 divided by 1 into 1, which is equal to 4, right? So finally I have limit n tends to infinity a n plus 1 upon a n is equal to 4, right? Now the test says if the value is greater than 1, then the series is divergent, less than 1, then it is convergent. So here this is 4, that means this is greater than 1, so which is greater than 1, therefore by ratio test the given series summation an over n is divergent. Now see, in this example, if I compare the given series with summation an for n plus 3 upon 3n minus 5 raised to n, then my an is this 4n plus 3 upon 3n minus 5 raised to n. Now here you have to think that why zero test, geometric series test, integral test, limit comparison test don't help us. Even more, if you try with ratio test, then you may observe that this limit will be more difficult to evaluate. So if I try with root test, then in root test what I need to evaluate? I need to evaluate nth root of an at infinity. So what is my an? Is 4n plus 3 upon 3n minus 5 raised to n, and I have to take nth root of this. So easily I can cancel out this n and which gives me very simple formulation of the limit 4n plus 3 upon 3n minus 5. By taking n common and n common, you can easily prove that this limit is 4 upon 3. Now here the analysis says if the limit is less than 1, greater than 1 or equal to 1. Now you have to check whether 4 upon 3 is less than 1 or greater than 1. This is greater than 1, and therefore by this analysis, when limit is greater than 1, the series is divergent, and therefore by root test summation an is Divergent. Started with zero test, geometric series, integral test, limit comparison, ratio test, and root test. So I was going and applying one by one test in the sequential manner. Now the question is, if I have given any random example, then how can I understand that which test I need to apply? For example, suppose I have given this example. Summation n is greater than or equal to 1 n factorial upon n raised to n. The second one is summation n greater than or equal to 1 n into sine 1 upon n. The third one is summation n greater than or equal to 1 upon n into ln n square. These are three examples I have given. Number of tests I have given. I only need to check which test will help to me. Now see. In all these examples, if you observe then, here I have factorial and n raised to n. Right. So over the factorial, if I apply integral test, that x factorial is not possible. So here integral test is not helpful. Right. Even more, in this example, I know that sine 1 upon x. This is very difficult to integrate. And so I don't think about the integral test. Clear? So in first two examples, I don't think about the integral tests. Obviously, all these three examples are not in geometric series also. Right. If I'm thinking about limit comparison test, right, then when I can apply limit comparison test? Only whenever I have given the series either in geometric terminology, for example 2 raised to n plus 1 upon 3 raised to n plus 5, or summation say 2 raised to n upon 7 raised to n, right? Or I have given the examples which has polynomial kind in numerator and denominator, n cube plus 7 upon say n square minus n plus 5, or you may say this is say n raised to 8 minus n raised to 3 plus 5n square minus 6. Then only, so these are the only two particular cases where I can think about limit comparison test. Otherwise, I don't think on limit comparison test. Now, in this example, this is n factorial. So suppose I am thinking on root test, then do you know what is n factorial raised to 1 upon n? No, it is very much difficult, right? So whenever the factorial notation occurs, I don't apply root test. But in ratio test, easily I can deal with n plus 1 factorial divided by n factorial, right? So whenever factorial notation given, I always apply ratio test. Here, what is happening? N and ln n. This is actually 1 upon n and ln n. What is the relation between 1 upon n and ln n? Is the derivative and integration relation. So I try to apply integral test here. So on these 5 to 6 examples, now if you think, observe your series and then think which test can be helpful. If your series has polynomial terminology, apply limit comparison test. If it has geometric terminology, apply limit comparison test. This is direct analysis by geometric series. You need to convert this in terms of 2 raised to n upon 3 raised to 5, and so it is geometric series, right? Here we have n factorial, so ratio test only. If you have one example, for example, summation, say 4 raised to n upon n raised to n, right? Then only root test, only root test, more helpful. This example, only integral test. This example, summation n sine 1 upon n, everything is difficult. Root test is difficult, ratio test is difficult, comparison test is also difficult. So there are always some special examples. So what we do in these kind of examples, we try to check with zero test first, right? So let us see what is happening with the zero test. In this particular example, what is my an? An is n into sine 1 upon n. So this can be represented by sine 1 upon n divided by 1 upon n. Therefore, limit n tends to infinity an is equal to limit n tends to infinity sine 1 upon n divided by 1 upon n. Now, if I assume that 1 upon n equal to m, then when n tends to infinity, 1 upon n tends to 0. And therefore 1 upon n is m, m tends to 0. So this can be represented by limit m tends to 0 sine m upon m. And you know that this is formula. Sine m upon m over m tends to 0 is equal to 1. So what is zero test? If limit n tends to infinity an is not equal to 0, this is not equal to 0, right? And therefore summation an is divergent. And so by zero test, summation an is divergent. In the next video, we shall discuss more random examples and we direct choose that which test can be applicable, and we give the guarantee that okay, with this test we are always comfortable to find the analysis whether the series is convergent or divergent.